Good morning, class. Happy Monday. Welcome to another week of learning about volume. And today we're going to do something super fun, okay? Because today we're talking about how to find the volume of objects that aren't necessarily easy to find the volume of. So do you remember when we played with these on Valentine's Day? These are my little heart stones. So how might we find the volume of this? It's not necessarily very easy to measure this heart because it's very irregularly shaped, right? But this is where we can figure out the volume of this heart by using water. So I have here a graduated cylinder, and it's got measurements on it so that we can see the volume of water. And right now I've put just 100 milliliters of water in here. And what we can do is we can find the volume of this little heart by putting it in the water and seeing how much the water rises, okay? It's like when you get in the bathtub and the water goes up higher, right? You're displacing the water and increasing the height of the water by your body displacing the water, okay? And so we're actually talking about displacement, okay? And this is your anchor chart for today's lesson. And what I want you to do is write down this first sentence in your spiral books, okay? So you can have displacement as your title and today's date, which is Monday, June 14th. And then please just write, when an object is submerged in water, it displaces a volume of water that is equal to its own volume. Okay, so just this first sentence, just the 3 lines. And pause the video if you need to, because this definition is important for today's lesson, okay? So take a minute now, pause the video if you need to write that down. When an object is submerged in water, it displaces a volume of water that is equal to its own volume. Okay? All right, and now we'll have a look at this, and stay tuned for us putting our heart in the water, because first we're going to look at page 83 of the textbook, okay, which shows us what it looks like. So it shows us that Sammy poured 50 milliliters of water into a measuring cylinder. Then he put in some marbles and measured the volume of water displaced by the marbles. Okay, so we see that we have our 50 milliliters here, and then when he's put marbles in, it looks like there's 8 marbles. It goes up 30 milliliters. Okay, so the volume of the cylinder before, the water in the cylinder, was 50 milliliters, but the volume of the water with the marbles comes up to 80 milliliters. Do you see that? It's now 80 milliliters altogether. And that means that the volume of the marbles is the difference, right? The difference from the new height to the old height. And that difference, you can do 80 minus 50, or you can just see it on the page, and it is 30 milliliters. Okay, so our 8 marbles have a volume of 30 milliliters. Okay, isn't that cool? So now let's do some of our own examples. Okay, so again, here's my graduated cylinder, and I've got 100 milliliters in here. So I'm going to start by putting 5 hearts, okay, into my cylinder. All right. So now, and I know it's hard to see through the video, but let's have a look. From my measurements, it looks like it's gone up 15 milliliters, okay? Because this is where the 100 line is. And because this cylinder goes up by 5 milliliters, it looks like it's gone up the value of 3 ticks, okay, from where it was before. So that means that the volume of my hearts is 15 milliliters, okay? Do you see how that works? So the beginning volume was 100 milliliters. And then after, it was 115 milliliters. So that means $15 milliliters. Okay, and because we know that I put 5 hearts into this cylinder, we can actually find out the volume of 1 heart, right? Because if the volume of 5 hearts equals 15 milliliter, then we divide that by 5 to find that 1 heart is worth 3 milliliters. Isn't that awesome? Okay, so let's look at some other things that we can measure using displacement. All right, so now I have here 5 dice. This is from a Yahtzee game, actually. So 5 dice, and I know dice are somewhat easier to measure because they are cubes, okay? So we could measure them with a ruler if we wanted to, but we can also use displacement to find out what their volume is. Okay, so we're gonna do that because that's a little more fun. All right, so I'm gonna put all 5 into my cylinder. 1, 2, 3, 4, 5. And again, I started with 100 milliliters. That's where we're gonna start for all of these. And now, let's have a look. Okay, so again, here's where 100 milliliters used to be. And now it has gone up 4 lines, okay? And again, we know that each line is worth 5 milliliters. So when we count up 4 lines, that means that we have gone up 20 milliliters. So what that looks like is if our starting volume is 100 milliliters and our ending volume is 120 milliliters, the volume of our dice altogether is 12 milliliters, okay? So you see the difference in the height. The new height is 20 milliliters more than the old height, right? So that means the volume of the dice that we put in to cause that change is 20 milliliters. And again, because we know we put 5 pieces of dice, 5 dice into the cylinder, we can divide this number by 5 to see the value of each die by itself. Okay, and that is 4 milliliters. So each die is worth 4 milliliters. Okay, and we can use displacement to find that out. All right, so let's look at another example of something that we can find the volume of using displacement. Okay, so my next example is coins. So I have quarters here. I've collected 10 quarters, okay? And we're gonna put them in our cylinder that again starts with 100 milliliters. And we're gonna see what their volume is, okay? So here we go. Okay, so I've got my 10 quarters in here, and it has only displaced 5 milliliters. So you can see this is where the 100 line is, and it's just gone up 1 tick, okay? So all 10 of these quarters are only worth 5 milliliters, okay? And that means that each quarter is worth half of a milliliter. Okay, wow, which is smaller than I thought. But isn't that cool? So you can see we can find the volume of different things by displacing the water that we measure, okay? All right, we're gonna do one more example just for fun, just because it's so fun. So again, we have our 100 milliliters that we're starting with, and now I've got some smaller dice here. These are dice from a game, and in my hand, I have 20 of them. They're so little, okay? So we're gonna see what all 20 of them are worth together. So let's do this. All right, we got all 20 in, and we have gone up 25 milliliters, okay? So this is our new line, and this is our old line. This is where we were before. So we've gone up 5 ticks, and they're worth 5 each. So that means that all 20 of these dice together are worth 25 milliliters, okay? Because we started with 100 milliliters, and we ended with 125, okay? So cool stuff. So that means each one of these is worth 1.2 milliliters. So they're just little guys, but we can measure them and find their volume by using displacement. So that is it for today's lesson, okay? And if you have at home a measuring cup that has the milliliters displayed on the side, I would encourage you to try this at home. You can find rocks or other irregular objects, of course, with your parents' help and permission, and you can examine the displacement that happens in the measuring cup. If you don't have a measuring cup that has milliliters, no worries at all. That is actually it for today. So then you are free to move on to whatever else that you're working on, okay? Because there's no homework attached to this lesson. All right, I hope you enjoyed this fun little experiment, and we will continue to talk about measuring displacement tomorrow, okay?